black holes, the objects that seem to illegally mess with the fabric of reality. Many have heard of black holes. Those who haven't, stick around. You might learn something. Those who have, you probably heard that black holes suck things in. And once you're inside, there's no way to get out. Or is there? To understand a black hole, we need to go back to when they were first theorized, by the man Albert Einstein himself. When he came up with his theory of general relativity, which I briefly explained in my previous video, he realized that for his theory to work, there needs to be something in the universe that broke all known laws of physics back then. But Einstein, who was a man of physics after all, decided that he made a mistake. He really did not want black holes to exist, and denied their existence whenever anyone asked him about it. But black holes got other scientists thinking. Einstein was always so smart, and they saw nothing wrong with his theory of relativity. But if there was nothing wrong with the theory, that would mean that black holes really exist. Later, in 1967, the scientist John Wheeler made up the official name for a black hole, which was, well, black hole. Before then, it was called a singularity. But now, we use the word singularity to define something different in black holes. But I'll get to that later. Then, in 1971, the very first black hole was spotted through a telescope. That changed everything. Before then, black holes were just an idea that might work. But now, black holes are very real and very dangerous. Then, not that long ago, in 2019, we got our first picture of a black hole. This is what that looks like. Not the best quality, but keep in mind that this black hole is 25,500 light years away. And, might I add, this picture was taken by the Event Horizon telescope. But enough about history. What the heck even is a black hole? Well, put simply, a black hole is a dead star. Yeah, you heard that right, a star. The reason a star burns is because it is huge. Stars, when they're just born, start out with hydrogen inside of them. And, using something called nuclear fusion, which I explained in my second episode, mashes the hydrogen atoms together to create helium atoms. Our sun right now is a hydrogen star, and it is slowly burning into a helium star. Fun fact about helium, it is the only element that we have ever discovered outside of Earth. Instead, it was discovered in the sun. And because of that, helium is named after the Greek god of the sun, Helios. When a star runs out of hydrogen, it grows in size and becomes way hotter, and starts burning helium into carbon. Carbon then starts combining with helium to make oxygen, and once all the helium is gone, carbon and oxygen combine to make silicon. And silicon combines with two carbon atoms to make iron. But iron is strange. Iron is really stable, so it doesn't like combining. When the star runs out of carbon, oxygen, and silicon, it only has iron left. The star becomes hotter, trying to combine iron atoms together. But iron is stubborn and refuses to combine into tellurium. The star's core becomes unstable because of this and disintegrates. The core is a very important part of the star. It holds the star upwards. Once it's gone, the star collapses on itself. Since the star is huge, all of a sudden, all of that star's mass starts getting packed into a tiny spot. Imagine crushing the Earth down to the size of a peanut. That's what's happening to the star. Because of this, the atoms in the star get in a violent fight with gravity. Now, two things could happen. Either atoms win or gravity wins. If the star was small enough, the atoms will push against each other to stop the collapse. When they finish, what will be left is a tiny neutron star, which is really hot and has a lot of gravity. However, if the star was big enough, gravity will keep pushing on the atoms, crushing them more and more until they collapse into a single point called a singularity. This point is infinitely small and infinitely dense. It has infinity gravity and is the most dangerous object in the universe. Quickly, a shell forms around the singularity. That shell is the black part of the black hole. Since the gravity around a black hole is so extremely powerful, if something gets too close to it, it will fall in and get squeezed into an infinitely small point once it reaches the singularity. Nothing, not even light, can escape the grasp of a black hole. This is how a black hole looks like. Different parts of the black hole are named different things. This ring around the hole itself is called the accretion disk. It is a disk of all of the things that the black hole tried to suck in, but failed, and got it stuck in orbit instead. The singularity you already know about. It is a point right in the center of the black hole that is the reason the black hole is so dangerous. This part, right here, right at the edge of the black hole, is something called the point of no return. You can escape the gravity of a black hole as long as you don't cross this point. Imagine a river with a waterfall. The water gets faster and faster as you come closer to the waterfall, but you could still escape if you tried. But when you reach the edge of the waterfall, it is the point of no return. You cannot escape. The official name for this point on the black hole is, get ready, the event horizon. That's why I named my channel that, because hopefully, once you click on my videos, it is a point of no return, and you'll want to watch more. Hopefully. For about 2 years after the first black hole was spotted, people thought that black holes were immortal. They were born, and they will never die, a hunking evil presence in the universe. But in 1973, Stephen Hawking proposed the idea that black holes can die if they don't suck things in. He observed that whenever a black hole sucked something in, it became bigger. But if it didn't suck anything in, it would eventually shrink. But how? The only way a black hole can shrink is if something escapes it. But that's impossible. Stephen Hawking proved different. As I explained in my very first video of Event Horizon, when conditions are right, particles of light can crack open and release a particle of matter and antimatter. Near a black hole, it is absolute chaos. And when light gets sucked into the black hole, near the event horizon, it breaks into two. Most of the time, when a photon, which is like an atom but for light, breaks apart, it releases matter and antimatter. Those two bits are then magnetically attracted back to each other and combine to create a photon again. But when this happens near a black hole, when a photon breaks apart, the black hole sucks the antimatter particle in. The other particle, which now has no partner to combine with, instead shoots away from the black hole in the form of radiation. This radiation is called Hawking radiation, in honor of the man who discovered it. The antimatter particle, however, gets sucked into the black hole. But since antimatter is negative, instead of making the black hole bigger, it shrinks the black hole. And if a black hole goes for a very long time without eating anything but antimatter from light, it will eventually evaporate and vanish. Okay, but who cares? Why should humans even care about black holes? Sure, they're cool, but they're so far away. Why do we even need a black hole? If we figured out a way to safely open a black hole here on Earth, we would be in luck. Trash is building up here, and a black hole is a mega trash can. And as a bonus, we could use the Hawking radiation coming from the black hole as extra energy, so that we can close all of the oil and coal companies that are ruining our air here on Earth. And with extra research, we can find out what happens if we get sucked into a black hole. Currently, all we know is this. As you jump feet first into the black hole, the gravity in the hole will pull on your legs faster than on your head. That will make you stretch. The scientific name for this stretching is spaghettification. That is because you won't reach the singularity without becoming a thin noodle and eventually snapping in half. But if we do figure out a way to safely make it in the singularity, in the black hole, we really don't know what will happen. But my favorite theory is that the singularity is a portal to an alternate universe. An alternate universe is a universe that looks like ours, but has some very weird and interesting differences that would be very cool to look at. This has been Event Horizon. Dang it. This glitch has been happening for the past 2 months. Have you noticed anything weird? It's like the universe is trying to tell me something. Ow!